Good morning, everyone, and welcome to today's class. This is Work by Energy lecture number 26. We are dealing with lecture number 26. What was discussed in lecture number 25, which was, I think, 3 or 4 days before your vacations? Anyone can tell me what was discussed in the last lecture? Par. Yes, Karthik, that is correct. We were discussing par. We had seen two types of par, instantaneous par at this instant, and we had also discussed average par over a interval of time, and we had seen the relation between instantaneous par and average par, which is coming to you right now on your screens. Average par is total work divided by total time. It is integral of f dot dr with integral of dt. It is same as your average velocity or average speed, as we had discussed. Instantaneous par is f dot v. It is the par at this moment in time, which is same as your instantaneous velocity or instantaneous speed. We had also seen what I call as the average function and the relation between power and average par. Average par, as you can see in green, average par is instantaneous par into dt, integral divided by integral of dt. We had seen what this average value function is. Whenever we want to find the average of anything, it is integral of f dt divided by integral of dt. If it is average over t, if it is average over x, it is integral of f dx divided by integral of dx. It is average over s, m, n, whatever. So we had seen that averaging function. Yes or no? Do we all remember this? Can I have some raise hand that we remember this part up till here? We can recollect what we had done in the previous class. Can I have some raise hands that we understand this? Okay. Okay. Only 6 people seem to understood this. What about the others? Yashwant, Veronica, Tarun, Shriya, Satvika, Sana, Sai, Pranav, Teja, Jay Shankar, Deepak, Ajay, Rahul. Do you all understand this beta? That was a quick recap of what we had done in the previous class. Now, in today's class, as you would have guessed, we would be discussing par and finishing this topic of par. To finish this topic of par, we must now solve some numericals based on this. So we would be doing that. We would be solving some numericals based on this. But before going on to numericals, we would see some formulae that would be important for us to see this. So here they come. Someone, I'm getting noise from someone, so I'm just muting everyone out. So this is what we are going to discuss. This is a simple derivation that has been done, and it is there in the sheet that I have already sent to you. I hope you have received that sheet. That was there in your group already. I have sent it 5-6 days ago. Now basically this deals with the position and the velocity of an automobile with respect to time. So this is a simple derivation. Simple is a formula that can be derived. Now, what is the condition of this formula? Of this formula, you have an automobile of mass m, which is accelerating, starting from rest. Remember that. So this car or this automobile or this bus or train or aeroplane, it is having a mass m and it is starting from rest, while the engine supplies a constant power P. Now, this is a question which has come many times in JEE Main as well as in advanced in IIT-JEE. The power is constant. So the engine is going to supply a constant power. We have to find the position and the velocity of this automobile with respect to time. So this is basically a question which is now being done in the form of a formula. So basically, what conditions are given to you? The first condition that is given to you is the mass of the automobile is m. Mass of the automobile is m. It is starting from rest. I've underlined it. Remember, I've told you how to read a question. Whenever you read a question, you mark the important points. You only get one chance to read a question. If you can't read it in one chance, you are using the time of some other question in solving it, which is not a good sign. So I have an automobile of mass m which accelerates, obviously, because I am going to apply a force on it. That is how it is going to start a journey. It is starting from rest. Engine supplies a constant power P. What you have to find out is velocity and the position of the particle, if I call it x, as a function of time. That is what you have to find out. In this particular question, I'll give you 2 minutes. Think about it. The solution is already there in front of you, but I would request you not to read the solution, but solve this question on its own merit. Power is constant, P is known, M is known. It is starting from rest. You have to tell me the velocity as a function of time. That means you can use T as time. Tell me the velocity of the particle, first question, as a function of time. Then we can proceed further. 2 minutes. I hope everyone is trying the question. Can I have some raised hand that you are trying the question, sir? Because if you're not, I will do my part and solve the question now itself. Only Harshita is trying the question. Okay, I'm getting some raised hand. 6 people, 8, great. Yashwant, Vijay, Veronica, Tarun, Suren, Satvika, Pranay. Okay, everyone is trying the question. Great, great, great. I'll give you a minute. I'll give you a minute. Solve it. Suren was telling me integral of f dt divided by integral of dx. I don't know, Suren, what do you mean by that? I have not asked you the average of anything. So I guess you are telling me the answer for the average value function. I don't know how it matters here. So I hope you can look at the question and tell me how it has to be solved. Power is constant, and that is how you need to solve it. I'll give you a minute more to think about it. Okay, now is the time that I solve this question. It is a pretty simple one. We'll solve one more on this line so that you will be able to understand this. So basically, power is constant. When you say power, you basically mean instantaneous power. I told you that. Instantaneous power is F into V. It is F dot V. But here I am assuming that the angle is 0. So this power becomes F into V into cos of 0. Cos of 0 is 1. So it becomes F into V. This is constant. F into V is constant. Now this F, if you remember, force is mass into acceleration into V. Now this acceleration is dv by dt into V. So we come to this step. This leads to this step. Power, which is P, which is constant, is equal to m into dv by dt, which is m into A multiplied by V. Then it is very simple. I take dt on this side. So here it becomes integral of v dv. M is also taken this side. You can also keep m on the left hand side, not a problem. So this becomes integral of p by m dt. P and M both are constant, so they will come out. It will be simply integral of dt. Now you can integrate it in two ways. You can integrate it by indefinite integral, or why you need indefinite integral? You can use definite integral. Velocity is varying from 0 to V because it starts from rest. So initial velocity is 0 and final velocity at time t is V. So velocity has been integrated from 0 to V, and time is also integrated from 0 to t. So you can use definite integral instead of indefinite integral. And when you do that, you will end up with the answer, and the answer would be simply V is equal to 2 times pt by m ka square root. Do we understand this? Can I have some raised hand that we understand this and we were able to find out the velocity of the particle as a function of time? You can use definite integral, you can use indefinite integral, doesn't matter. Both ways, you would be ending up with the correct answer. V is 2 times pt by m ka square root. You can also write it in this fashion, root over 2 pt by m. I hope everyone has understood this. I'll give you a minute to note it down. This is velocity of the particle as a function of time. Anyone has any doubts? You can raise the doubt. Copied, Vahini, good. Okay. Now that was velocity as a function of time. The next step is to find out position, which is x, as a function of time. So now that is the next question, x as a function of time. You must remember that when time is 0, that means when the question starts, the value of x is taken as 0. So you know the integral limits. Time की integral limits is from 0 to t. X की या position की integral limits is also from 0 to x. 2 minutes now, your 2 minutes starts now. I'll wait for your answers. 2 minutes. Well, I hope everyone has tried this question. Shall we go ahead and see how it is to be done? And here it has to be done. So I know from the previous section that velocity v is equal to 2 times pt by m ka square root. Now this v can be written as rate of change of position dx by dt. Here they have written it as ds by dt. Doesn't matter ds by dt or dx by dt. So dx by dt becomes 2 times pt by m ka square root. So I can take dt on this side. So on the left hand side, I have integral of dx. I will write it as integral of dx. And on the right hand side, I have 2 pt by m ka square root multiplied by dt ka integral. So how will I write it? 2 pt by m ka root is a constant. So I will take it out of the integral. 2 p by m, which is a constant. I will take it out of the integral. It will be simply integral of t raised to the power half into dt. It is a very simple integral, t raised to the power half dt. It will be simply equal to t raised to the power 3 by 2, t raised to the power 3 by 2 divided by 3 by 2. So you will end up here. Now you can put the limits of time. Time ka limit is from 0 to t and x ka limit is from 0 to x. I hope everyone understands this. X ka limit is from 0 to x and time ka limit is from 0 to t. So you don't have to get to this step where we are going to find out the value of the constant term. We can simply use definite integral. That is always better. Don't have to look for the constant. Use definite integrals, and once you put the value of time as 0 and x as 0 and time as t and x as equal to x, you will land up with this promising result. And the result looks like this. X, which is the position of the particle as a function of time, would look like this. 8p by 9m raised to the power half t raised to the power of 3 by 2. Do we understand this? Can I have some raised hand that we got this answer, sir? Raised hands will give me a lot of confidence. I hope everyone has understood this. Yes or no? If anyone has any doubt, you can ask me the doubt. I'll give you a minute. This is the answer. X is equal to 8p by 9m under root t raised to the power 3 by 2. I will give you a minute to note down the entire solution of the answer for the position of the particle as a function of time. I'll give you a minute to note it down and then note down the answer. Then we will move on to the next question that I have created for you. We'll move on to that. 1 minute. If anyone has any doubt, you can raise a doubt at any point in time. I'm getting some message on the chat. Let me see. Again, the Surennath is again. Okay, that is probably from the previous. Suren is repeating the same thing. Okay. Well, I hope all of you have copied this. Congratulations. Then that takes us to the next question. And the next question is already there on the board, which I have already written. How does the question read? Power of a car. I'm not going to underline this. You'll have to see and do it on your own. Power of a car, P, is given as A into T, where A is not acceleration. Okay, let me not take it as A because A might confuse you. So I'll just take it out as, let me write it as alpha into T so that you don't get confused between A and acceleration. So power of a car, P, is given as alpha into T, where alpha is some constant. So you know what is alpha. T is the time. The car has a mass M. So mass of the car is given. Starting from rest, so car starts from rest at time t is equal to 0. So when you start the question, when you start the description, time is 0 and the car starts from rest. The value of x, the coordinate is also 0. Find a, which is acceleration, v, which is velocity, and x, which is position as a function of time. You have to find the acceleration, velocity, and x, position of the particle as a function of time. Remember here, power is not constant because it is a function of time, so it will change with time. So power is not a constant, but that will not change anything in the question. I give you 2 minutes to solve this question. Let us see who gets me the correct answers. 2 minutes is all that you have to solve this. Best of luck. Well, let me ask, has anyone tried this question? And is there someone with any type of answer that you can tell me? Any answer, anyone? Acceleration, velocity, and position as a function of time. Anyone has any answers? Let me see. I have got one message. Vine is saying V is 0. Anyone else? V is 0 at time t is equal to 0. Vine. What about the other times? Anyone has any other answers? Anyone has tried this question? No one tried it? Can I have some raised hands of students who have tried this question? Only 3, 5. That's sad. What about the others? Why are you not trying the question? If you don't participate in the class is useless. Because I don't think you will find it interesting while you are seeing it in recording. And if you don't follow the class in the first go, it wouldn't be an interesting class to attend while you are seeing the recording. Jayashankar, Venkatesh, Wahini, Tarun, Satvika, Sana, Sai. I guess most of you are trying the question but not raising hands. Manasa, I understand that because I see Wahini is not raising hand, but she was trying the question. Krishna, Kushi, maybe it's a I don't I really don't know the mm, experience of having an online class because I've hardly attended any online classes. I've already given online classes, but what I would always suggest or do is instead of seeing this class on a laptop is a good option if you have it. Most of you probably are watching this class on a mobile phone, which is not such a good way of watching it. It is very small and you might strain your eyes. I think most of you would be having a laptop or a system at home, a computer system at home. It's better if you can watch that class on a computer system. That would be a good option. The best option, however, is if you have a good smart TV on your in your house and you have a mobile phone. You can mirror your screen on the TV. I know you are gadget friendly and you would be able to do it. Big screen with a table on. That is the best way to watch the class. So you have the entire class on a big screen. So it becomes a personal experience, and that is how I would have done it if I had to attend a class like this. I have a TV monitor, so I will sit in front of the TV monitor with a small table, screen my mobile. If it is a smartphone, you can just screen your mobile onto that, and you have the entire class coming on big 50, 60-inch screen, and that would be good. Anyways, that was my take on how to attend a class. No matter how you are doing it, whether you are doing it on a mobile phone or an iPad or a tablet or a laptop or a computer screen or a monitor, there must be an answer if you're trying it. I guess when you're trying the question, it is difficult for you to raise your hands. I understand that. So I will not insist on you raising hands, but I will insist on you telling me whether you have tried the question or not. Anyone with an answer? No one with an answer. So what I will do is I'll do my job and I'll solve the question myself. What is given in the question? In question, it is given that power is alpha t. And from here, I start. Power is alpha t. I also know that power, which is power, instantaneous power, is F into V. So these are the two starting points that I have. One more starting point. I mean, everything I'm writing in red, which are the starting points. This power F, this force F will be mass into acceleration, mass of the body multiplied by acceleration. This acceleration A will be dv by dt, starting points. And this V would be equal to dx by dt. These are my starting points. And once I understand these starting points, I'm writing it You don't have to write it in this way because remember, JEE, whether it is main or advanced, is just a matter of time. No question has ever come in a JEE apart from the JEE of 1995, where the questions were pretty tough. No question ever has come in a JEE which cannot be done in the time which is given to it. Given sufficient time, you should be able to solve any JEE question. The only thing that matters is how quickly you can do it in the examination hall. Okay, power is alpha t, power is f into v. Now I start. So alpha t, which is power, is f into v. This becomes my first step. Step number 1. Now it's pretty damn simple. I can just put the value of f from here into this, and I will get the first answer, and the first answer would be the value of acceleration as a function of time. What would be the value of acceleration as a function of time? Tell me, anyone. Acceleration as a function of time. Will you get it from here? If I try to do it from here, what will I get here is alpha t is equal to m into a into v. Now here, from here, I will not get the value of acceleration as a function of time because I must understand that I also have a v here. So I'll get acceleration as a function of time and acceleration as a function of velocity. So I will not get the first answer here. But wait, don't panic. You can keep on doing the question further ahead. Now, look at the green one. You have A coming here, which is acceleration. And you already know the green thing, acceleration is dv by dt. So you can move on to the next step. I'm writing the next step here. What would be the next step? Anyone? What would be the next step? Anyone? The next step would be alpha t is equal to m into dv by dt multiplied by v. Do we all understand this? Can I have some raise hand that we understand this? Yes, all of us understand this. Then it is pretty simple from here onwards. I can just take dt on this side. So what do I have? I have the next step which is coming here. So I'm going ulta. So I have alpha t dt is equal to m into v dv. This is what I get in the next step, which is now circled, which is now in a square. Now I can just put the integration limits, velocity varying from 0 to v and time varying from 0 to t. Do we all understand this? Can I have some raised hand that we understand this, sir? What I have done here, I have put the integration limits, nothing else. And now I will integrate this. So I will get alpha into t square by 2. I will have to put the limits of time from 0 to t. On the right hand side, I will have m into v square by 2. I will have to put the limits of time or velocity from 0 to v. That will take me to the next step. And from here, you can find out the value of velocity as a function of time. Can you now tell me what is the value of v as a function of t? This 2 and this 2 will get cancelled. Okay, now you tell me what will be the value of v as a function of t? Anyone? I'll get v as root over alpha by m into t. Do we understand this? Can I have some raised hand that we understand this, sir? I will get v as root over alpha by m into t. Now I need raised hands from everyone that, sir, yes, sir, we understand this. Only 11 people have understood this. That is not a good sign. All of you must understand this. If there's any doubt, you have to raise your hands and let me know where is the doubt. Harshita, Satvika, Sana, Sai, Pranay, Padmakant, Manasa, Sainath, Krishna, Kushi, Shashank. I hope Kevin, Jay Shankar, Satya, Ajay. I hope everyone has understood this. Great. Now from this step, I can now find out the other two answers. Remember, remember, acceleration here is dv by dt. So acceleration is dv by dt. If I simply differentiate this equation with respect to time, I must get the value of acceleration as a function of time. And if I differentiate this, what do I get? I simply get acceleration as alpha by m. Very important result. Acceleration as alpha by m. The result in green, acceleration is dv by dt, which is root over alpha by m. Alpha is a constant, m is a constant, there is no t. That means my acceleration is coming as constant. Do we all understand this? Even though power is varying, your acceleration is coming as constant. A very important result to understand. So that means when the power is constant, then acceleration is not constant. But when power is varying as alpha t, acceleration is coming as constant. I hope everyone understand this. So now I have two results. The first result is in pink, which is v as a function of t. V is equal to alpha by m ka root into t. The second result is the value of a, which is the derivative of v with respect to t, dv by dt, which is alpha by m. I'll give you a minute once again. Can you now give me the third result? The third result is blue one, x. Initially at time t is equal to 0, x is 0, remember? To give me the third result, x as a function of time. And how much time you have to solve this? You have 1 minute to solve this. X as a function of time. 1 minute. Anyone got any answer for this? I'm waiting for the answer. X as a function of time. Anyone? No one has an answer? That would not be good. One more minute. Anyone has an answer? 3 participants have raised hands. So let me see who all has raised hands. Surendra, Reddy, Yashwant, Tarun. Okay, you 3 have raised hands. Anyone would like to tell me what is the answer? You can unmute yourself. Surendra, you're ready. Tarun, you can unmute yourself and tell me what is the answer. No one?
Sir, root over
Root over
root of alpha by m t square.
root over alpha by mt square. I hope you are not missing anything. Are you missing anything? How do you do it? Tell me, how do you do it? So basically from this step, what you have to do is you just write v as dx by dt. Am I correct?
Yes, sir.
So dx by dt simply becomes root over alpha by mt. What will be the next step, bacha? Ashwant?
Integral.
I'll take dt on this side, correct? So my dx would become root over alpha by m into t dt. Is that correct, Yashwant? Am I doing
Yes,
it
sir.
correctly? Okay.
Yes, sir.
What will be the next step? What do I do now? Yashwant, what do I do now? Oops, I've not shared the screen. Okay, Yashwant, what do I do now? So this is the first step that Yashwant told
Sir,
me.
apply integral, sir.
Yes, this is the first step. Sorry, just give me a minute, Yashwant. I did not share the screen. So this is the first step that Yashwant told me, sir, put v as dx by dt. So I've done that. Then in the next step, which is step number 2, I have taken dt on the other side and put it like this. Yashwant, what is the third step?
Sir, put integral on both sides.
Put integral on both sides. So that is what I'm going to do. Root over alpha by m will be outside of the integral because it is a constant t dt. What should be the next thing that I should do, Yashwant?
Sir, integrate, sir.
Shall I put the limit as well here from 0
Yes,
to
sir.
x?
0 to x.
And time is from?
0 to t.
Okay, then I simply integrate it. What is the value of integral here? Dx simply becomes x, and this is to be integrated from 0 to x. And on the other hand, we have alpha by m, and then I have t square by 2, isn't it?
Yes, sir.
Integration from 0 to t. What is the next step then?
Sir, x equals to
The next step would
what?
definitely be, let me write it as step number 4. X will be equal to
Root over alpha by m t
t
square by
square by 2. Did you miss anything, Jashwant, in your original answer?
Yes, sir.
What did you miss?
I have missed by 2, sir.
Why? What was wrong? What did you do wrong?
I was doing double integration of x, sir. I was integrating with respect to dx of dx, sir. So that was I have done mistake.
So then your answer would be, if you're doing that mistake, if you're integrating x dx beta, then your answer was more wrong, because if you integrate x dx, you will get x squared by 2. So
Yes,
you
sir.
will get
That was
x.
my mistake.
That was a big mistake, because if you integrate x squared by 2, 2 say 2 will get cancelled, and this root will again come here. So it will be root over this, right? So your
Yes,
answer
sir.
would be definitely very wrong, right? You
Yes, sir.
got it? So you
Yes,
should
sir.
not do this mistake. I will just erase this mistake. So this is the correct answer that you must all get. Is everyone there on the same page? Do we have The concurrence of everyone that, sir, yes, sir, we think this is the correct answer, and this is how Yashwant has done it. A simple mistake. I can forego that mistake. But the concept is definitely clear. Thank you, Yashwant, for letting us know your thought. Thank you. Do we all understand this? Only 10 people seem to have raised hand. That is not good enough because there are many more in the class. So I would request all of you to note down this solution as well as raise your hands to let me know that we are good to go. Yashwant, Vijay, Shriya, Satvika, Rakesh, Pranay, Pawan, Padmakan, Krishna, Khushi, Karthik, Sashank, Kevin, Deepak, Aishwarya, Satya, and Ajay. 2 minutes you have to note down this entire thing, and then we'll move on to the next part and do 1 or 2 questions from your sheet, and the rest will be left for your practice. 2 minutes, solve it and note it. If you have any doubts, you can always raise your hands for your doubts. I'm going to lower all hands now, so if anyone has doubt, you can now raise your hands. You can ask, you can unmute yourself, you can ask your permission to unmute yourself, and you can speak and let me know your doubts. Okay, 2 minutes. Well, I hope everyone has noted this down and copied and you have understood this. Let us now move on to the next question, which happens to be the last question from your sheet. Then the last question from your sheet is question number 74. And this is the question that we are going to do first. These are the type of question that you can expect in an examination hall. That is why we are doing it. Remember, what we have discussed in the class today is the first case was the power was constant. Remember that. In first case, power was constant. In second case, power was variable. Power was alpha t. And from that power, we were getting constant acceleration. From that power, which was varying, we were getting constant acceleration. Remember, 2 different cases. The next problem, problem number 74, goes like this. A constant force F. A constant force F is applied on a body. The power P generated as a function of time is what? So your force is constant. You have to tell me how does power vary with time, and if you just apply common sense, you should be able to tell me the answer straight away. And that is how you save time in an examination hall and you score marks. If you've done something once, you remember it. My mom used to tell me that to sharpen your memory, you eat badam. Now, I don't know what badam is called in English. I hope you can help me out with that. So you mash up this. So in the night, you soak this badam What is this badam known as in English? I'll have to Google it. I don't know the names. I'm very bad with names of vegetables, name of almonds. Yes, man. Thanks a lot. Almonds. I'm very bad with 3 4 things. See, I can't just learn. Thanks. I can't tell you the name of vegetables in English. I can't tell you the name of fruits in English. I can't tell you the names of all these dry fruits in English. I just can't do that. I'm not, and I can't tell you colors. I can't tell you the name of colors. I only know 3 or 4 colors. Red. I can imagine red, blue, black, white, green, yellow, pink, black, brown. Yes, these are the colors that I know. I even don't know what is gray. I just get confused. Might sound stupid, but that is how it is. So almonds, mash them. You just soak them 3 or 4 in water. You soak them overnight. Soak them in water at night. In the morning, you mash them. You take a glass of milk and you mix this mashed almonds in the milk, and you shake it up and just to drink it. That sharpens your memory. My mom used to say. I tried it. It worked. If you can't do this much, just eat almonds. They sharpen your memory. You need that. You will be needing that. You will be needing that because once you done a question, if a similar question comes, you should be able to give me the answer straight away. And what is the answer for this problem number 74? The answer is straight away. We have done this. What is the answer? How will power vary when acceleration? No, not acceleration. Force is coming as constant. What would be the answer? Almonds is not the answer. Almond is what badam is called in English. What is the answer for this one? No one knows the answer? And the answer is straight away option B. Power is directly proportional to time. Do we understand this? If I go back to the question that we had done, we had taken power as alpha, which is a constant multiplied by t. So power was directly proportional to t. From there, I was getting acceleration as constant. If acceleration is constant, acceleration is force divided by mass, or force is mass into acceleration. If acceleration is constant, then force has to be constant. That means if force is constant, power is directly proportional to t, and hence the correct answer is B. Do we understand how we apply what we learn in the class and how we get the answers straight away without doing anything? And that is how you save time. And once you save time, you can score heavily because it's all about a matter of time. And how do you save time? You have to become efficient. How do you become efficient? You have to solve more and more questions. And that is the only way. If you don't do this, well, you might know a lot of things, but you will not be able to perform. You need a lot of practice. You must have seen all these cricket players, they hit big sixes, they score runs. They just don't score runs because they have talent. Yes, they have talent, but they practice hours and hours and hours in net. Then only they can do that in the actual match. Don't practice, you will not be able to perform. So I would request you to practice a lot of questions. Even if you just practice the questions that are given in your sheet, that are much more than enough. I always insist. The last question we have done is 74. I would request you to do the rest of the question. 73, I'm just rolling it up. 72, 71, 70, 69, 68, 67, 66, 65, and 64. If you have done these many questions, I'm sure whatever question comes in the JEE in this topic of power, you would have covered each and every question. I leave it to you to do this. I'll end my class here. I hope you have enjoyed this class. If there's any doubt, anything that is troubling you, you can always come to me. I'll end this class here. I hope you have a nice day and you study, work hard, and practice a lot. Take care. Have a nice day.